I am going to explain what a full stack developer does and what technologies one would work with. And it's a natural extension to talk about what a back and a front end engineer do as well. I'm going to use those terms interchangeably, developer and engineer, because in our context they mean exactly the same thing. The logical place for me to start is what is the tech stack, because I don't know where you are coming from. It could be that you already know how to code some and you're looking for a job and you keep seeing full stack back end and it's just a little bit confusing. You could be posting a job or just starting your coding journey and have no idea what these mean. So we'll just break down the different pieces of the technology stack, what the different options are at each level, and then we'll circle back to what a given engineer works on. Okay, so like most of my good videos, this starts with a really big box. We're gonna live most of our time here and then I guess explain over here. Okay, but this thing represents a server. Okay, scary word, we gotta start somewhere and we gotta define it. A server is, I'm sorry to disappoint if you were looking for some really complicated fancy answer, but a server is just a computer. Okay, what you are watching this on, whether you're holding it in your hand on your phone or it's a desktop or laptop, you could be running a server on that device. And I say that because AWS is a cloud server. Okay, that's another sort of myth, is that a cloud server is something special, and it's really just somebody else's server, right? That's what a cloud server is. It's just a server that doesn't belong to you. But AWS, their cheapest server, and I'm sure the same thing's true for GCP and Oracle and Azure and so on, but it has like half a gig of memory. And it has less than one core, I think, for a virtual machine. And I've run multiple websites. Now, they didn't have high traffic, so there's obviously limitations. But what a server is, it's less about this stuff, the CPU and the GPU and the RAM and the hard disk, right? All the stuff that you know what makes a computer. It's less about what it is and more about what it does. Your computer is not a server, even though it could be, and even though it may actually have Apache web server on it, because a lot of MacBooks shipped that way. It's not, because you use it to browse on the internet, right? To do social media stuff, to play video games, to talk to your friends. Maybe it's your business computer and you use Microsoft Office or Google Docs or whatever, right? That's why yours isn't a server. What would make it a server is just, I don't know, two examples. Maybe it's running a script that processes a bunch of data, okay? Something that a programmer would do, okay? It could also be that maybe it is handling web traffic, right? It's functioning as a web server. So you've got your website hosted on it, right? Again, stuff that a programmer has done is running on this thing. So it's a computer because of what it does, not because of what it is, or rather like the special hardware on it. And all developers are going to interact with an operating system at some point, sort of. So the very first thing we need to talk about, because every computer has one, is the operating system. Okay, and we're going to make a line there, and it will become clear why. But there are only two operating systems that you really have to choose from. There is Windows Server, and then there is Unix. Okay, you say, hey Rob, what about Linux, right? Yes, sort of. Okay, we're gonna answer that question. We're gonna come back to it. Okay, but Linux is another option. And you say, hey Rob, what about other operating systems like you know Android or Mac OS, or more to the point, like more server type stuff? It would be more like maybe Ubuntu or Red Hat. I'm gonna put up here, just because you're familiar with it, iOS and Mac OS. And let's do one more. Let's do Fedora. Okay, etc. What about those? Are those operating systems? Well, yes, sort of. let me explain. It's going to take just a minute to unpack what an operating system is and do a tiny bit of history in order for this to make sense. Please stay with me, because this might be the first time you've ever heard this, and it's really, really helpful for understanding how the ecosystem works. Okay, an operating system, and this part you may have seen me do before, is really two pieces. Okay, there is the UI, which is the user interface. There's some kind of interface, whether it's a prompt and you type in, or whether you can drag your mouse around and click on Finder, click on Windows Explorer, open documents and stuff. This you interact with and you know how it works, because when you install software, the software uses the UI, and so do you. Okay? The other thing that makes up an OS is the kernel. The kernel interacts with this, right? Somebody has to, right, actually use the CPU. These two things talk to each other. Okay, so you want something to happen, or your software wants something to happen, or your Python code wants something to happen. That is a UI thing that tells the kernel and then goes and does the ones and zeros, okay? And then, right, reports back or whatever. So this is internally how an operating system works, okay? I'm gonna take a short hop into the 60s, all right? And again, like this is, I wish I had known this a long time ago, but there was a lab called Bell Labs, which is owned by AT&T. And it is the closest thing that I know of in the modern era to like a, I don't know, an Avengers research facility, like a Wakanda, where crazy next level stuff was going on there. So much of the technology that you use today, you know, came out or is thanks to what was going on at Bell Labs. It started, I guess, in the 20s, I think, but up through, we're going to talk about more like in the 60s and 70s. Just as a couple fun for instances, they invented the laser there. They invented solar panels there. They invented the transistor there, which is really, really important for CPUs because, well, anyway, we'll keep going. A transistor works like this, where current comes down and it has to go one way or the other. That's essentially what your CPU is made up of. They came up with what turns out to be like imaging ability, so like color cameras, MRIs, X-rays, that kind of thing. Essentially developed computer networking in its modern sense. Okay? Go do some research. It's super fun, like a rabbit hole to run down. Why does this matter? Well, let me clean the board up quick. Okay, so why bring up Bell Labs? Well, there were two crazy smart guys there. Actually, there were tons of crazy smart guys there, but these two guys, relevant to us, Dennis Ritchie and a guy named Ken Thompson, we'll stick with the Marvel metaphor. These are like Tony Stark type guys who invented some crazy awesome stuff. They created Unix. Okay? As just a quick side note, Dennis Ritchie also made C. He has since passed away not too long ago. If you don't know what C is, it's a programming language that probably every device you have is either programmed in C or programmed by something that was programmed in C. So like for instance, Python is programmed in C, Java, at least the JRE, is programmed in C, and so on. Ken Thompson made the Golang at Google. So these two guys put together Unix. Why does that relate to Linux? Why go through all of that? Well, again, Unix is this thing. It's an operating system. It had a UI and a kernel. It came out in 1972. We hop forward to 1991 because they didn't release it until the late 70s. And in 1991, another guy shows up named Linus Torvalds. I'm sorry if I butchered his name. But Linus was, I think, a college student at the time in Finland, or at least he was Finnish-American. And he hacked, for lack of a better word, the Linux kernel, or the Unix kernel, out of Unix and called it Linux. Okay? So that means what we have here is only half of an operating system. It took the kernel from Unix, called it Linux, but there still needs to be a UI. What are the options for UI? That's all of this stuff. There is Ubuntu, right? Is a distro of Linux. We could replace this with Red Hat, or with iOS, or with Android, or with Slackware, or Mint, or name your thing. Okay, so that's why this is a little bit tricky to understand, is there is Linux, which you almost certainly are working on as a developer. If you're not a Windows developer, like in this ecosystem specifically, you have all of these other options. Well, they're all using the Linux kernel, which came from Unix, but they're not using the Unix UI, they're using their own UI. Okay, let me clear this up again quick. So that covers the operating system part in basic. Really, you've got just the one option of Windows Server that kind of creates your ecosystem for the rest of the way up. Now there's, as Microsoft has become more progressive in recent years and technology has just gotten better, you usually can cross over, but in general, you kind of stay in your lane. You're either Linux person or you're a Windows person. Okay, the next one up we go is the web server. Okay, this could be any type of network traffic managing thing. And on the Windows side, IIS is the typical web server that Windows would use. On the other side, you'd have Apache, you'd have Nginx, you would have Tomcat, you'd have WebSphere, and the list, there's a whole bunch. You can technically manage network traffic directly with the programming language. I typically don't do that. I can explain why maybe a little bit later. But the web server is going to be that thing that manages your HTTP traffic, or again, if you're talking more generically, network traffic. How does it work? Well, you have a server, right? Server. And you have your program on here, okay? The program itself does not handle traffic. Something else does. And again, like I said, technically it can, but you have the internet out here, and the internet comes in on port 443. That is the HTTPS port. So on the Linux computer or the Windows computer, that's the port that's listening for HTTPS traffic, which is google.com, right? Is facebook.com, is amazon.com, name your website. Well, you will have somewhere on here a web server that's listening there, and then typically your program internally would talk to that thing. At least that's the main way that I do it. So the web server is incredibly important. The network trafficking manager, whatever, handles all of the traffic that comes and goes. Okay, let me clear this up quick. The next layer in the stack is the database layer. And for the Microsoft side, that is typically going to be SQL Server, which is MSQL, or Microsoft Access. On the other side, the Linux side, there's tons of options naturally. I'll just list off a few. There's Postgres, there is MySQL, there is Oracle, and then there's a whole bunch of NoSQL options like MongoDB, CouchDB, and so on. Okay? The database layer, what does that mean? Well, again, we've got our server here, and on there you have your program, right? Let's say it's a Python program. Your Python program needs a place to store data, right? And get data from. That is what the database's job is going to be. Okay, so as your program is running, it will go back and forth to get data, because Python itself does not, it can hold a small amount of data, but not the kind of data that we work with today. Let me give you a for instance. Think about in your kitchen. You only keep the stuff out on your countertops that you're actually cooking with. If you need something that you haven't used for a while, or you just started cooking, it's not your whole pantry sitting on top of your countertop. You have a closet, a pantry that you go and you get stuff out of, and then you use it, and then you put it back. That's what's going on here. The database is like a pantry, and when your programming language needs it, it will go fetch it, can do stuff with it, and then put it back in, update it, store it, whatever. Okay, so the database is crazy important. It's really the thing that makes most applications valuable, is the database layer. And again, like if you have traffic that's coming in, so the web server is right here listening for traffic, talking, it's going back and forth to the database. So that is that layer. Give me just a sec to clear this up. The next layer is the one that you are probably thinking about all along, would be the programming language. Okay, and for Windows or for the Microsoft ecosystem, that's going to be predominantly C#. There's also ASP back in the old days. On the other side, there's a zillion. Okay, we already mentioned C, we already mentioned Golang, there's Java, there's Python, there's all the other variants of C like C++, there's even a C++, there's PHP, there's Ruby, the list goes on, right? There's a zillion options you can put in here. I'm going to put in here JavaScript, kind of, because we're going to come back to that. What does that mean? Well, again, we kind of already talked about this, but on your server here, you have your program, which is just that. It is a program that your operating system runs just like any other program, just like Microsoft Office or just like a game. You have your code, which is done in a programming language that is going to interact with all of the other stuff. Okay, I'm going to pause here and hit the last one, and I've run out of colors, so I'm going to go back to pink. You also have at the top a framework, which is not absolutely essential, but realistically it is. The framework that the Windows ecosystem uses is .NET, and then over here it will depend drastically on what you're actually using. Like for Java, it would be Spring Boot, probably. For Python, which I think is next there, there's Flask, and there's Django. Node.js, which I left off, I guess I have JavaScript, but you might have Express on here. For Ruby, it would be Rails, right? Whatever. Okay, what is this? Well, the code that the developer writes, all a framework is a ton of code that somebody else has written so that you don't have to. So Flask is a bunch of Python that a Python developer can use. Express is a bunch of Node.js that a Node.js developer doesn't have to actually write. Rails, same thing, right? We've written a bunch of Ruby for you so that you can just kind of get off to the races. So the framework part is absolutely essential, I would say, at this point in history, okay? The last piece that doesn't belong to the server, okay, but is going to be part of the stack. Let me clean this up again real quick. I'm going to draw over here on the side is the UI, okay? And I'm not going to associate it with either one of these because technically it's going to be agnostic, okay? This is going to be, and I'll draw a computer here, a laptop. So this is the end user. Let's say that this is the browser, okay? The browser runs JavaScript and only JavaScript. That's why I put it over here kind of by itself, because JavaScript is a front-end only thing. It is a UI thing. It is a browser thing, okay? But JavaScript itself has its own framework in React and Angular and Ember and Vue, and I mean there's a lot of different frameworks. The main two I would say at the moment are React and Angular, but you have this piece of the stack as well, even though it's not part of the server, so that's why I kind of moved it off to the side. I cleared out all the clutter, all of the options and extra stuff, and I broke it back down into just the key elements of our technology stack as I have laid it out. The user interface, the framework, the programming language, those two go together, the database, web server, and the operating system. Okay, before we get down to this, which we're just about home, I want to draw out the process so that it's clear one last time. Okay, and we will do a web request as our example. That's supposed to be a laptop. The user has loaded up the UI, okay, which is also probably using a framework. Okay, again, JavaScript, React, or something like that. It's going to make a request to the server, which is running an operating system, right? There's a web server listening for traffic, right? Maybe this is Apache or Nginx or IIS. Maybe it's running on Windows Server. Maybe it's running on Ubuntu, okay? The web server gets the request and goes to the appropriate place on the server that it's told to, and interacts with the programming language and almost certainly the framework. Okay, this is Python and Django, or Node and Express, or Java and Spring Boot. The programming language needs some data, so it goes up to the database server. We didn't talk. I didn't break the database down a lot. It's another scary concept. It's really just a ton of Excel spreadsheets that have some awesome rules, so you can pull exactly the right columns or rows or cells or whatever. Okay, but the programming language goes to the database. They talk back and forth. The programming language processes what it needs. It gets finished, and then it sends it back out to the web server, who sends it back out to the user, and the user has their web page. Okay? This is the entire process, right? All of these pieces in their appropriate spots. Okay? So let's draw this out. The front end, what does the front end do? The front end is just this part. That's the only thing that the front end developer is interested in, is going to be the UI, which is going to be exclusively JavaScript when it comes to the web, okay? They're almost certainly going to be using a framework, as I said, React and Angular and Vue, there's Ember, there's lots of options, but the programming language for the UI is JavaScript. So all three of those comprise this portion here, okay? The back-end developer, actually let me underline that so that the color, so it's a little more color coordinated. The back-end developer is going to be interested in all of this stuff, okay? The database, the programming language, the framework with the back-end language, so the Python or the Node or the Java or whatever. The web server, not always, but probably usually, at least in my experience, definitely the operating system, at least locally, if not on a development server and not in deployment. Okay, and then lastly, the green, the full stack engineer is doing all of this. Now, don't get the wrong impression and think that that means that the full stack is a super developer, because uh, that encompasses both back and front end. That's not necessarily the case. If you have a senior with equal level of experience for all three, you might have a slightly better Java developer here than here. This person can also do Java, but can also do React, right? You might have a super awesome Angular developer. This person can do Angular, but they can also do Python, right? You get the idea. One's a little more, this is more utilitarian, going to be able to cover any base across the entire technology stack. These two are more specific, or, in the case of front end, a lot of times it's a starting point. Okay? This is a good stopping point. I hope this gives you a good frame of reference for how the technology stack works, how it interacts with itself, with each other, the pieces, and so on, and then what the individual engineers do. Whatever you do, like pick one of them out and chase it down, do some more research, but definitely keep learning and keep coding. Thanks for watching.